Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's easy puzzle is going to be a tessellation, it's called Silent Little Killer Tessellation by Michael Lefkowitz. And here are the rules. We have tessellation rules, where we need to fill each cell with a digit from 1 through 9. Cells sharing an edge cannot have the same digit. So this cell cannot have the same digit as the cells that are sharing an edge with it, which are these 8 cells. And each horizontal row and vertical column contains a non-repeating consecutive set of digits, like 2, 3, 4, 5, 6 in any order. So every row and every column must fulfill a Renban restriction, essentially. So they have to form a set of non-repeating consecutive digits. And finally, we have a silent little killer, where a digit in a cell with an arrow is the sum of the line of cells it points to. So for example, if this were, say, 2 and 5, this would have to be a 7 because this little arrow means this digit must be the sum of the 2 digits it points to. Similarly, this is the sum of the 3 digits it points to. This is the sum of the 3 digits it points to here. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. This can be... So... These 3 digits. Oh, there we go. These 3 digits have to form a Renban. This is the largest digit of it. And they have to be consecutive. So these 2 are consecutive. And it must be consecutive with this sum. Because of that, I think this has to be 1, 2, and 3 here. Right? Because if you try to have any other consecutive digits, 2 and 3 adds up to 5, but those aren't consecutive at all with each other. And this always must be the largest one, because it's a sum of these 2 digits. So this is always 1, 2, and this is 3. That means 1, 2, and 3 cannot be any of these digits here, because this is a 1, 2 pair, which is different. This has to be 4 through 9, and this is 4 through 9 here. 3 cannot be any of these cells. If this is 4, I guess that could work as 1, 3. So if there's a 3 on this row, it has to be one of these 2. There could also not be a 3 in this row. Can this ever be 9? And I think the answer to that is no. Because if this is 9... Also, this can't... Okay, so this is the sum of 3 unique digits, adding up to another digit. That means this is 6 through 9. But, and again, anytime you have 3 unique digits adding up to another single digit, you have to have 2 digits from 1, 2, and 3, right? The combinations are 1, 2, 3 adding up to 6, 1, 2, 4 adding up to 7, 1, 2, 5 adding up to 8, 1, 3, 4 adding up to 8, 1, 2, 6 adding up to 9, 1, 3, 5 adding up to 9, and 2, 3, 4 adding up to 9. Notice every one of those sets of 3 digits adding up to another digit contains 2 out of the digits 1, 2, and 3. So this has to be either 1, 2, 3, which it can't be because of the 3 in the column. So this can't be 6. This is either 1, 2, 4, 1, 2, 5, or 1, 2, 6 here. But this is a 7th length Renban, and we're guaranteed 1 and 2 here. Therefore, this must be 1 through 7, and therefore this is 7. So this is 7, which forces this to be 1, 2, 4 here. This is, well, they can be duplicates here. That leaves these as a 5-6 pair here. That eliminates 5 and 6 from being here in this cell. All 1, 2, 4 see this cell, so this can't be 1, 2, or 4. It could be 3, 5, 6. It cannot be 7. If it's 7, that would be 1 and 1 at maximum. Sorry, at minimum. And then, but that would be touching itself. So this has to be... This is at least 6. Again, 7, 8, and 9. It cannot... These can't be 1, 2, or 4. So this has to be 3, 5, 6, 7, 8, and 9 here. This can't be 5 or 6. Can't be 3. So it's 1, 2, 4, 7, 8, 9 here. I guess this could... Okay. I guess this could be 1, 3. This is 7. This is 6, 7, 8, 9. So that means this is at minimum 4, 5, 6. So 4 through 9 is here. This can't be 7 because of the 7 in the row. Again, this is at minimum 3, 2, and 1 because you can't have 1, 1 here with a 3. This can't be 1, 2, or 4 because this cell sees all these cells here because they share an edge with all of them. Can this ever be 9? If this were 9, the problem is you have 4 as the smallest digit here. But then a 5-length round band containing 9 only can be 5, 6, 7, 8, 9. So this cannot be 9 here. If it's 8, again, you have the same problem. This would be 3 and 5 here, adding up to 8 at minimum. Or sorry, the minimum small number here, adding up to 8 would be 3. And 3 cannot... Ugh, got a hair in my mouth. 3, excuse me, trying to take the hair out. 3 cannot form a 5-length rem band with 8. 3, 4, 5, 6, 7 is the max, right? So this can't be 8. This could be, so this is either 4, which makes this 1 and 3, or this is 7, and it would have to be 3 and 4. So if this is 1 and 3 and 4, this would be 5 and this would be 2. If this is 7, it would have to be 3, 4 here, because it would be 3, 4, 5, 6, 7. But the problem is 5 and 6 would both have to be here, and that would eliminate all possibilities for the cell because they would share an edge with it. So this has to be 4. This is 4, this is a 1, 3 pair, this is 2, this is 5, that's 6. This 1, 3 pair both touch this cell, so it's 2, which makes that 1. 6 cannot be here because of the 6 in the row. This is 2. This is 1 and 3 at minimum. So it's 3 through 7 at most. So this is 1 through 7. This can't be 6. This can't be 7. This is 2. So it can never be 2 through... It has to be 2 through 8 or 1 through 7 here. So 2 through 8 or 1 through 7. Cannot be 6 here. Cannot be 7 here. This is 1, 2, or 4. So it can be 4, 5, 6, 7, 8 at most. So this cannot be 9. Okay. This is a 2. So this has to be 1 through... it could be 1 through 5 or 2 through 6 here. So 6 cannot be here because of the 6 in the row. Okay. This is 1, 2, or 4. So this is 4, 5, 6 at most. So this can't be 7 or 8 here. It could be 1, 2, 3, or 1 through 6. It cannot be 4 and a 4 here because of 1 or 4 in the column. This can't be 4 because of the 4 in the column. This is 6. It could be any combination so far. Oh, this can't be 1 or 3 or 4 because of the 1, 3, 4 triplet here, which all share the same cell as that. Or share an edge with that, shall we say. Hmm. Hmm. Okay. What digits can this be? So this is at least 1 and 3, so this is at most 5. So this could be 2, 3, or 5 here. Say this is 1, 2, 3, then that would force this to be a 5 here. That's possible. So it could be 1, 5, and 3. Um, hmm. So this is done. This is done. This is kind of done. This is, I don't know, kind of done. Oh, if this is 6, this would be 1 and 2. But then this would not be able to form a Renband because 2 sees all of these cells because they share an edge. So this cannot be 6. This has to be 3 or 5. Can this ever be 2, 3, 4? Adding up to 9. So to add up to any digit without a 1 being here, it would have to be 2. It would have to be 2 here, 3, and 4. That could work. 2, 3, 4. So this can never be 2 here. If this is 2, oh, it could be. 2, 3, and 3 does work. Oh, wait, no, that doesn't. If this is 2, I don't think this can ever be 2. If this is 2, that would mean this is 3 and 3, guaranteed. But then this 2 has to be in a Renband of 3 length, and therefore would require 3 here, but we have a 3 here, which is not allowed. So this cannot be 2. So 2 is one of these 2 digits there. We cannot have 1 and 2 here. It could be 1, 3, 5, 3, 5, which would force us to be 9 here. Can it be 1, 2, 3? No. This can't be 1, 2, 3, because if that were 1, 2, 3, this 1 again does not have a Renband that works. This can never be 4, because either this is 1 or 4. If this is 1, this can't be 4, because it'd be 1, 2, 3. If it's 4, it obviously can't be 4 because of 4 in the row. So if it's 1 here, this must be 2 and 3. So if this is 1, this has to be 2 and 3. Because this can't be 2 because of the 2 in the column. If this is 4, this would be 2. That would have to be 3. It can't be 1, 3, 3. So if this is 1, you have to have 2 and 3 here. So then this would be 5. And then this would be 3. If this is 4, it has to be 2 and 3 at minimum. So this is 9 every time. You can't have, well, you can't have 4, 3, 3. It has to be 4, 2, 3. Again, if you have 1 here, you can't have 3 and 3 here because this is 2 and 3 there. And they both see that cell. So this would have to be 5. If this is 4, it has to be 2 and 3 to add up to 9. So this is adding up to 9 either ways. That forces this to be 8 and forces that to be 7, which eliminates 7 in the rest of the row. So this is 5 or 8 here. This is guaranteed to be 3. That eliminates 3 in the rest of the column. 9 is here. This cannot be 7, 8, or 9, so it's 1 through 6. 8 cannot be here because of 8 in the row. This is 4. It could be 3, 5. Or it's 4, 5, 6. Either of those work. 3 cannot be here because of the 3 in the row. This is 9. So this can never have 1 and 2 on this row. It has to be 3 through 9 here, which forces this to be 4. So this is 4, which makes this 1, which makes that 2. This cannot be 1 or 4. No 1 or 4 here. No 1, 2, or 4. This is 2 and 3. Can't have 2 here. This can no longer have an 8 because it's 2 through 6. This can't have 7 then either. This is 1, which forces this to be 2 and 3. That forces this to be 5, which makes that a 6. So this is a 4, 5 pair here. 3 eliminates 3 in the rest of the column. So this is 1, which makes this 3. This must be 1 through 7 here then. Well, that means this must be 5. This has to be 7 because that's the only place for 7. This 5 eliminates 5 here. So that's 4, which makes this 5. That makes this a 6 here. So this cannot be 6 here. And here. And here. This can't be 5. And this can't be 5. There's no 3 available here. This can't be 5. This can't be 7. So this must be 6, which forces this to be a 2, 4 pair. To be a Renban. This 6 eliminates 6 here, so this is 5. This can't be 5 or 6. It's 7, 8, or 9. This has to be a 3, 8 pair to form that Renban. This cannot be 2, 3, or 4. This 5 eliminates 5. These can't be 5. This is a 1, 4 pair here. One of these is 4. One of these is 4. That eliminates 4 in the rest of the row. So this cannot be 4 here. Remaining digits in column 5 are 3, 7, 8, 9. 7 and 8 cannot be here. This can't be 7. 9 can't be here because we're guaranteed that one of these is 1 or 2. So this becomes a 3, 8, 3, 8 pair, which eliminates 3 and 8 in the rest of the column. So this can't be 3, this is 9, this can't be 8 or 9, so it's 7. Remaining digits in row 5 are 1 through 5. This digit, we need a 3 in this row. 3 cannot be here, so 3 has to be here, which makes this 8, which makes this 3. That eliminates 3 in the cells touching it. So none of these can be 3. This can go up to 5 at most. So this is 1, 2, or 4. Where is the 3 then in row 5? It has to be here. So that's 3. 2, 4 both touch this, so this cannot be 2 or 4. So this is 1. Which makes this 1, 2, and 3. This 2 eliminates 2 here, so it's 4, which makes that 2. 1 eliminates 1 here, so it's 4, which makes that 1. This can't be 1, 2, or 4. That makes that 5. And that's the solution. Yeah, fairly straightforward. This was the sort of tricky part here. But other than that, the tessellations actually force this to be pretty restrictive. So we had a lot of restrictions on where we could place digits. Yeah, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.